Okay, hello guys. Welcome to our lecture 11. Today we'll be talking about data abstraction. And data abstraction is covered in 200 and 210 at DVC. I guess it's 210 though. So let's get started. So study goal is what is the data abstraction and what are the constructor and selector and what is abstraction barrier. So you get started. Like, suppose you are preparing for a DMV driving test. It's like um, to test your ability to drive. And then what stuff you have to do to get it prepared? Like going to one of DMV offices and how offices test you. They test you to build a brake engine? No. Test you to build the gas pedal? No. To build the gears? To build the engines? They are all no. Like you don't have to be a mechanician to drive a car, but about to know how to speed up the car, to know how to stop the car, how to switch gears, how to use mirrors. Yes, like they're basically everything like you have to when you go on the road, you have to speed up, have to slow down, and you may want to back up as well. And this can be like the things inside in your driving seat. They may Yeah, they may have the gears and the mirrors so that you can use them. And they are the tools. So after knowing how to use these tools, then you get the license so that you can drive. So how are they related to programming? The stuff I said like actually happen every day in our life. So the data abstraction is like to store the data with some logic, but you don't have to know about the logic. You just have to know how to use some tools to store the data or maybe want to access data, like to know something, maybe, or you want to store something inside. You don't have to know about the logic that it may require, but you have to use some appropriate tools to do all the things. So in programming, it's basically when it comes to collaborating, you may not do the whole project by yourself. When someone already built something, you just use a tool provided by him or her with no need to figure out why. So it's like when you're doing programming, maybe with a lot of people, and you're not going to finish the program on your own. You have to like there are some parts like you may use some existing tools to store or to access the data. Otherwise, you may get like all the things messed up, or maybe you get some in chaos, or maybe something dangerous happen. And but the internet just got interrupted, but it's okay. I'm back. So um, yeah, like when you try to do a very large project with other people, they may already build up some tools for you, and these tools are used so that you can actually store the data or access the data um, into a correct database or maybe in a safe database, so everything will not get messed up. Like this is data abstraction. For example, in real life, when you want to drive, you don't have to figure out why when you hit the brake, the car will stop. You just have to know like the brake is a tool in my driving seat that once I hit that, the car will slow down and stop. Um, so you don't have to figure out why I hit that, or you don't have to build another system like when you're driving. Like you don't have to like create some methods to reduce the speed on your own. because we provided the brake and you just hit that, the car will slow down or stop so that you can do it, finish the job in the appropriate and the safe way. So all you have to know is like when you hit the brake, the car will stop, or otherwise, yeah, you may not get the car stopped safely and appropriately. So this is data abstraction. So data abstraction is like having a system with like maybe you know the logic or maybe you don't know the logic, but it's okay. We just provide a system that like how to build a system is other people's business, other people's task. And your task is like having this system, like assuming that it already works very well, works as expected. And then your job is like to use the tool that is created or you already exist to store the data or to access the data only using these tools. And yeah, and maybe you know or maybe you don't know the logic, but that doesn't matter. So we have two tools to um, to access the data and to store the data. How to access the data? We access the data using a specific tool called Selector. And to build like, or maybe you want to store some data, you use Constructor. They are just conceptually, they are just some concepts. Actually, you have to use the provided selector and constructor in a specific program. Um, but they are like a concept, you know, oh, okay, this is selector function and this is constructor function. I would just use them to create something I would like to, or maybe to access the data that is already stored well. So let's see what the examples of selector and constructor and the data abstraction. Suppose I want to store some vectors into program. Vector, I can briefly talk about what is a vector. Maybe someone don't know. Vector is like when I have a coordinate, um, I will have I will have a vector which showing the direction and the coordinates from the original point. Suppose this is in x is 1 and on the y-axis is 2. So this vector is 1, 2. So I want to store this. I want to store uh, like where from the origin on the x-axis and where from the origin on the y-axis is the location or the place we're going to store the place or the location, and they will be represented how far from the x-axis and like how far on the x-axis from the origin and how far on the y-axis from the origin. So we are going to create some to store some vectors in our program. So let's see, for example, 0, 1 and 2, 3. We have constructor. Constructor is like the tool of building, or maybe more correctly is like storing a line of data, uses the logic you don't need to know. Yeah, it's okay, you know, but you can like pretend yourself you don't know, but um, the logic doesn't matter. You just like assume that that works well, and then you can directly use the tool to create the stuff. And also the selector. Selector is the tool of accessing data. So they are stored well, and you may use some tools like suppose I want to spare the car, I will hit the gas pedal. So the selector is like the same, the tool, so that you can select and then you can access the data stored in the database. Okay, constructor. So for constructor, for vector, I would define vector xy. Vex is the distance from the origin on the x-axis, and y is the distance on the y-axis from the origin. So I will store the list, return x or y, and this is actually, you can say this is the logic. Actually, this is the logic of storing the data. Um, but you will not need to use, you will not need to, you can actually know about it, but you can also pretend you don't know, And because we don't actually use the list directly, we will instead use the function vector. The function vector itself is the constructor function, and it will create the data for us, although it's stored in the list type or a list form, but it doesn't matter. Like we store the data like that, but yeah, doesn't mean like maybe we actually have to know about it. No, you just treat that as a tool, and then know that okay, it will return a vector for me. And the selector is like I will use two selectors. One is that I want to get access to the x component of the vector, so I will return vector 0, and then y return vector 1. You don't have to know about the logic of how I access the data in the selector function. You just use the function, and then it will return the correct result for you. You don't have to know about logic. Maybe sometimes it's okay to know about it, but you don't have to. This is the concept of data abstraction. So this is constructor is like it's like the engine of the car. So it's like the very core stuff. Uh, you can say it is a machine or something. Um, it's like it will try to run and do the task for you. But if you really want to use the tools and something, you have to use the clutch, gas pedal, and the brake. And this is a tool that you can use so that you can use this stuff. Or maybe I can like add the steering wheel, but I what I mean is like um, these tools you can use so that you can control the machine. You don't have to control the machine by when it's running, you stand beside it and then try to like um, kind of touching the machine itself, or maybe you don't have to because we already have the tools for you here. And when you know you want to stop, you just hit the brake. The brake is a tool, and then using the tool, you can control the machine. So this is selectors. So now I have stored the data, and I want to use the data for further use. For example, when I have a vector addition and subtraction, like I want to do an algorithm, which is like I want to do some addition and subtraction between two vectors. So I want to write two functions. One is for addition, one is for subtraction, and then subtraction. And then we will use the constructor and selector function. So suppose I have the add vector. So the u and v are two vectors that we want to add it up together. So like think about what will the stuff be when I want to do two vectors adding up together. What will be returned? The stuff will be returned is a vector, a new vector. And how I actually make that this vector, like for the u and v, they all have their own x components and y components. So the new x components of the new vector is like, of course, the summation of the two x components from these two old vectors, and so as y. So um, the components in u and the x component of u and the x component of v will be added up together, and it will be the new x component of the new vector, so as y. So y will be the same. So it will return a vector, and I also have to get access to the components, x components of u and x components of y as components of v, and then add it up together. Also have to get access to the y components of u and y components of v, adding up together. And I'll put in the place, then I have to construct it as a vector. So um, this is how I do the add vector algorithm. And the first one is the selector. The selector is like because um, we can only use the tool to get access to the data, and then we can only use another tool to build the data, to build and store data. So how can we get access to data? We have to use selector. And then selector is like we get access to um, we get access to um, the X component using the X component selector, and also the Y component for the selector Y component. So you can get access to the corresponding place, the component of a vector. And then once you get that, because these are functions and they return the components you want. So and then just add them up together. And then the next step, after finding them, you have to use a constructor. Although you may know like I have the list type, but we can only use the tools that provided. So which is the constructor vector function. So the vector function will return what we believe is a vector, and then it will have the X component adding that together, because this at this corresponding place, this will be the X component. And at this corresponding place, the second place, it will be the Y component. So according to the math we've learned, um, like you will add them together and put that here, put the X at the first place and put the Y at the second place. And then you use the vector constructor function. So it will construct you, then you give you the returned vector. So this is addition. Also the same as the subtraction. The subtraction is like you have also the selector, select the components, and then put it in the corresponding place. And then you have the vector construction to make it to a vector. Like so that you have the add and subtraction algorithm, so that you can use them directly to do the algorithms between two vectors. Yeah, and yeah, yeah, so this is constructor and selector. So when you want to build data, use selector, select something from the old data, and then use the constructor to construct using the old data, like combine them so that they can be a new data. So this is how you use constructor and selector. So abstraction barrier. So supposed to drive a car, like it's reasonable that like when it's like when you ride a bike, you have to step your foot out when like when you don't want to use the brake, you step the foot out of the car and try to make it stop. No, like it's reasonable. You want to create your own braking system, like I just don't want to use the brake that provided. Uh, so I don't think that's reasonable. So I think other people will think that's unreasonable as well. So yeah, since that we provided the tools, like you use it, you get, I guess, 90% safely and appropriately. So when you try to build other systems, um, you will increase the probability of danger and chaos. So um, so there's actually a barrier that is like between us, the users, and the machine. Like when you actually try to control a machine, you will use some buttons there. Maybe you also have steering wheel, gears, and maybe like a car, you have a brake and the gas pedal. You use this tool, and these tools connects to the user, like for example you, and the machine, for example the car. Um, it actually connects it because so that you can use so that you can control the machine at this point, and using the gears, and another point, the machine will get affected by you, get controlled by you, because they have a barrier at between, and you have the and then you have the tool, and the tool can cross the barrier between you and the machine. So the user and the machine, there is actually like uh although you think like um this is kind of like yeah, but like what I want to say is like you can actually try to control the machine like in your mind, actually kind of like, or maybe just simply touch them or something. Like you must have some tools so that you can control the machine safe and properly. And so because there's a barrier there, when you cross the barrier, you will be you put yourself into danger, put yourself in a chaotic place. So it's better like you keep the barrier between you and the machine. So the barrier between the machine and the user in programming is called abstraction barrier. The users can use the tools to control the machine outside of the barrier. Like if you want to modify the machine, like mechanics, uh, you may cross the barrier when the machine stop running. But when it's actually running, like you can modify the machine, like because you are actually using the machine. When you use the machine, you want the machine to have the functions running. So uh you can actually just like modify the machine. In data abstraction, programmers must use constructors and selectors to use and create new instance of stored data. Although you may know like how the data is stored, so otherwise, you will break the abstraction barrier because you have to remember you are in the role of user. You are not the mechanics there, like you are not the machine. You are the user. So as a user, you can like cross the barrier to control the machine with your mind. It's not reasonable. You can modify when it's running. It's not reasonable. Um, but you have to use the tools can cross the barrier for you, and you can safely control that. Um, and the tools are constructors and selectors in programming. Mhm. So, so breaking the abstraction barrier can be dangerous. So these examples breaks the abstraction barrier, and then I will show why is it dangerous. So suppose I have these two vectors and I think I can assume that these two are vectors. Mhm. Um, Wait, first, I don't think we can assume them as vectors, but like suppose they are just lists. So like when you know that like you store the data, you actually use the list type, and then you may write a code like that. Like because I know it's a list, so that I can use the places, the relations of places, because the first place, like the zeroth place, stores the x component, and the next place will store the y component. You know that. Suppose you know that, and then you use u and v, and to create that. But um, but this can work for any list. Suppose I just wrongly put in the list that is saying um, string A and string B. So I have two characters here, and because because these two are not numbers, they're actually not vectors. So when I put this into the add vector, um, if you try to find out the x component and you just simply say u of 0, you get an A. And when you have u of 1, you get the character B. They are actually not numbers, but you still want to do the addition with a character and a number, which is simply you create a type arrow. If you don't cross the abstraction barrier, like in other words, when you use the tools, for example, I have X component of it. Although I didn't actually write like to check if when I create the vector, like, although I actually didn't say to check each instance to see if they are numbers or strings. But if I write that in the X component, in the X component function, I would say to check if like at the zero place and the next place, the first place in programming, to check if they are numbers. If they are numbers, it's okay. If they are not numbers, I will release the arrow, although I release an arrow message, or maybe I'll just like skip that, like to handle the situation, saying that, oh, it is not number, so we can proceed that. But when you do u of 0 and u of 1, you actually don't have the system of filtering. In other words, you will just let the arrow, you just let the string add the numbers together, so that you must create a type arrow, and then the arrow will crash your program. When you do as component and the vector function, you can add like, I want to prevent stuff except for numbers coming into my function. So then if in that situation I may not have the correct data, I will filter that out before forming or maybe accessing the data. So, but if you do u of naught, u of 0 and u of 1, you actually lack the step of filtering out some wrong information and wrong messages. So this is only one of the examples when you break the abstraction barrier. This may cause a very severe error. So we better just keep away from the barrier, try to avoid breaking the abstraction barrier by using the tools that provided in the programs. Yeah. If Python stuff is not a vector, but something else, oh, maybe even an empty list. If you are having an empty list, you have u of 0 and u of 1. It basically just like um it basically just like have the arrow like this out of the range, or maybe a list with only one element. Maybe like if you have only one element, it will also cause the list out of range arrow. So if you actually use the X component function, maybe you can filter that out, right? Maybe you can filter that out from the beginning to say, here's empty, we can use this. So, so this is one of the examples, one of the circumstances when you break the abstraction barrier and try to use your own method to do the calculation by kind of like avoiding all the tools. You don't want to use the tools provided. You use your own way. So this will cause a danger. So let's move on. So selectors can filter out the wrong data before letting the wrong data go into the next step. Constructor can store the data into the right database so that you can make sure that the data are not wrong. So as I said, like you can filter out by actually you can filter out in the selector or the constructor function, so that before things go wrong, you can filter that and stop them and handle the situation. So this is the why selector and constructor tools are important. Yeah. So we can try and determine if they are breaking the abstraction barrier. So I have the constructor and selector here. So like if you don't want to break the abstraction barrier, I guess you use all of the uh, two functions, including constructor and the selectors. So we can check it out one by one. So define subvector and I do use the selector function, but how am I going to construct my result? Oh, okay. The person here uses the list type like a square bracket. So he may know how we store the vector, but he didn't use the vector function. He knows how we store the data because he used the same method as we used in the constructor function. But like it actually returned a list. But it's not it can like you can say it's a vector and you can say it's not a vector because we don't use constructor function. If we had the filtering algorithms in the constructor vector function, like maybe I would type something wrong there, and then I would type something wrong there, and then you say uh, in the vector function, we can actually filter that out and handle the situation. But for here, the list type, it will not handle the errors for you. So the next one, because we know it breaks because the person here didn't use the constructor function. For the subtraction vector function, um, we can check another subtraction vector function. So we have u and v here. So we return vector, okay. We actually use the constructor function. So what the next one? Oh, you use the list again. Like I guess the person also knows that how we store data, but he also like knows this is a list and I can just get the information from the 0th place and the 1st place. But like he could not get a chance of filtering out some wrong informations because lists can store anything, but for our selector function, we can only have numbers inside. So um, so it also breaks the abstraction barrier, and it can also lead to danger because if I add some X component and Y component, add some filtering algorithms in the X component and Y component, we can handle that situation. But you never get a chance of handling some wrong information by only using by using U of 0 and U of 1. Yeah, so it also breaks the abstraction barrier. So the practice is like we use the constructor and use the selector functions to get all the functions to complete all the functions so that it can verify and return correct results. So we have magnitude, we have the dot product and scalar multiplication between like used in one vector or maybe used in two vectors. So we have magnitude of vector function. Like it actually represents how long the distance between the point and the original point. So the magnitude in math is usually like it would be d equals the square root of the x component squared plus the y component squared, and then the dot product. The dot product returns a number. The magnitude also returns a number, and the dot product also returns a number. So the dot product is like we get the component from the vector one, and we get the component from the vector two, x component, and then you multiply them together, and so as in y1 times y2, and then you add them up together, and this will return. This is the result we want. And for scalar multiplication, we have a number and a vector. So we have x and y component in the vector. So for the number, you will times each one, and then you have a new vector. This one returns a vector. So you should use the vector function at this scalar multiplication function so that you have the vector is like x and y, and this is the number n, and n times s and n times y. They both create a new function, and this is the function we want to have. We want to get it returned. So magnitude, dot, and scalar. So for the sake of time, I will just show the answers. I'll just show the answers. So we can actually put them. So we also have these functions. So for the magnitude function, we just use square root function. Like I include the square root. And from this point, we can just access the data directly. We will instead um, use the selector functions. We have the x component of the vector. So we'll just use, yeah, we have, because we have to square each of them together and add them up and then do the square root of the whole stuff. So we use power function. Power is like, and then we will use, or maybe we can do this. We don't have to use power. We can do as component of the vector times basically the same stuff. Component of vector. And then we plus the y component of the vector times y component of the vector, and make sure. Yeah, so this is x squared plus y squared. We can actually directly find the vector. We can directly find the x component of the vector and the y component of the vector because it will break the abstraction barrier. So this is the magnitude, and we now do dot product. Dot product is like we have to return the vector, so we should use the constructor function. So the left side of the comma will be the new x component, and the right side of the comma will be the y component. So how we do? Oh, this does not return the vector. Oh, sorry. Um, we have to do the summation. So the summation is like the left side of will be the x, the product of two x's, and the right side will be the product of two y's. So we get x component of vector 1 times the x component of vector 2. So it will be y component of vector 1 times y component vector 2. Sure. Yeah, this is x1 times x2 and y1 times y2. So we can access the x and y components directly because it will break the abstraction barrier. We both use selectors though. Yeah, we all use selector functions to get the x and y components of each vector. So scalar multiplication, we return the vector. So we should use the constructor function. So the new x will be the left side at the left side of the comma, and the new y component will be right side. So we can get x first. So we can just do number times x component of it. Yeah, and number times y component of vector. So yeah, I guess this is what we want. So we get a new x component by multiply the number with the old x component, so it's y, and then put that at the vector function, which is the constructor. So we'll get it. So we can try one of them. We can try all of them. So we can say V1 will be the V1 will be the constructor, the new vector. We call that 1, 2. And V2 will be the vector of let's say 4, 3, and 5. So this is a constructor, and then we can use as component. I also do a demonstration as component of V2 will be 3, and then the Y component of V2 it will be 5. Yeah. So V1, V2 actually are vectors, and you can treat that as a vector. So, and then you can just do everything with it. So we can do magnitude of V1. Let's see. V1 is like 1 squared is 1, 2 squared is 4. So it's square root of 5. Yeah. So square root of 5 compared with 2. They're the same. Okay. So, and then we do the dot product between these two. V1, V2 is 13. Is it true? Like 1 times 3, 3, 2 times 5, 10. So add up is 13. Yeah, that's true. So we do scalar. Scalar, we can just try A with V1. So yeah, although yeah, it returns a list, but we can use V3, store into V3. A, E1. So X component of V3, 8, and Y component 16. We can actually create a function. We can create a tool like I don't know it's selector or constructor, but you can print the vector out, print vector. So suppose I put in vector V, I'll just say the vector. So you can just print you can print I guess this one, and then you have to make it closed, and then we just print x component of vector, print, print, mhm, print the comma, and then print y component of, yeah, I guess that's it. Then just print, just return nothing. Okay, so we can try syntax error missing. Well, missing parentheses. It's been a long time not using the print function, so yeah. So we just create vector 3. It's vector of 1, 2. So print vector. Oh, I see. Can you slide that? It should be the one I want. So can convert string. I see. So yeah, this is the one like actually the one I want. So this is how we print vector function. Okay. So yeah, I think that's it for today's lecture. The data abstraction is actually like the first it's actually the first wait the first lesson of actually creating a user-defined data. So it's like we although we have the x and y a list here, but you can treat like when I have v1 equals vector of 1, 2. So you can actually just treat v1 as a vector. Although we don't have the I'm not sure if we had the vector like data type building data type in Python, but you can actually like say you can treat v1 as a vector, and um this data type is actually created by the programmer. So um next class we'll be talking about trees. Trees is like a lot of like branches and leaves, and we will use data abstraction for first. Like although we will make a tree kind of like a list, but you have to treat that as a new data type tree. And also is more like a conceptually thing for today's lecture, like data abstraction, provided that we have our like sometimes you may have your own system of building um like have your own system of storing a data and accessing the data, and you have to use the provided tools to finish your task. You are not going to create your own path. You are not going to create your own method of finish some task. And this may be dangerous and may be unsafe because you will get things messed up. And yeah, so this is data abstraction. So is one is that you create your own data. This is the first lesson of creating a user-defined data. And the next thing is like conceptually, when the program requires you to have to use some tools, you better use them, because when you use your own way of doing it, you may cause chaos, you may cause error, because the barrier, the abstraction barrier is like when you drive a car, you can only use things like steering wheel and brake, gas pedal to control the car. You are not going to modify the machine when it's running, and it is unreasonable. Like when you want to use the machine, you will use the tools. The tools will cross the barrier between you and the machine. It will help you control the machine and help you, yeah, control the machine in a safe way. Also, a reasonable way. So that's it for today's lecture. It's like kind of my more conceptual, but yeah. So that's it for this week's lecture. And next week we're going to talk about trees. Yeah. So have a wonderful weekend. Yeah, we finish. So bye bye.
Bye bye.
Bye bye.